Hi folks, this is Mr. Ege, and today I'm going to demonstrate you how to create a rocket car, and each one of you will get a piece of balsa wood. It's a big thick balsa wood, and everybody is going to have the same size balsa wood, but you're going to design a different aerodynamic shape, your own aerodynamic shape, similar to what I'm going to design here, or maybe different, quite a lot different. It's totally up to you. And when you're designing this the car profile, you're going to be considering reducing the weight, reducing the friction with air, because this car is going to go extremely fast. This car is going to go within an eye blink the entire runway. So that's why it has to be designed in a particular way. In the meantime, you're learning how to use CNC machine, and also you're learning how to use user interface of the CNC machine. In this case, you're using a program called Aspire. Spire command. Spire program is used to create a toolpath, solid model object, and also toolpath, okay, to instruct the cutting procedure to the CNC machine. CNC is short for Computer Numerical Control System, as you already know, and it is actually no more different than a digital router, okay? You give the hard objects, metals and plastics and wood, and it just basically machine cuts it very, very accurately. But you have to create the digital solid model first, and then you convert digital solid model into toolpaths, okay? This is the purpose of this. So the design that I'm going to show you, okay, will take you almost nothing for you to create by hand, but everything will be your fingers and your mind and your design, sense of design. So you will learning this process, okay? And also I hope you to enjoy it as well. So where do you find Axiom? Axiom will be in the Windows applications at the lower left-hand corner, and you're going to go to My Applications, and from inside the My Applications, you're going to find the Axiom. And when you find it, okay, click on it. If you can't find it, call me as usual. Okay, if there's any problem and insisting problem, call me and I will be next to you. Make sure that I will be with you and solve this problem. So as soon as Axiom starts, one of the first things I do, I go to File and click on New. Okay. A new button will give you job setup page on the left. As you can see, job setup page will ask you a few questions. One of them is whether you want this single-sided or double-sided or rotary. There are three options available. Single-sided is means only the top surface, computer working from the top surface. Double-sided means it's going to be both sides, and the rotary is there is going to be turning the wood or lumber or metal, whatever it is, okay? So in this case, we're going to click on the single-sided if it's not already clicked. If it is clicked, then you don't need to click again. Second, the piece of lumber that I will give you is a balsa wood, extremely light and very soft, so be careful, and write your name on it too. Will be 12 inches long. And the height of the balsa wood also will be the y direction is 2 3/4 of an inch. Okay, 2 3/4 of an inch, or 2.75 inches. And finally, the thickness of the wood will be 1.625 or 1 5/8 of an inch. Okay, so we're using only inches in this case, not millimeters. Okay, so units are inches, is marked here. Next, please pay attention to where the Z position is. Z position is aligned to the top surface of the wood. And that's very important to click on the material surface. You don't want to click the machine bed. That's different approach. And some people may do that, but that's my instructions strongly recommend you to select the material surface top left. If you go to machine, the red dot on the image will go down, and that's going to totally screw up the instructions I will give you. So that's why material surface on the top left has to be selected. And then next, on the next box, you have XY datum position. Datum should be at the lower left-hand corner. When you look top down on the plan, when you look top down, the 00 reference point has to be at the lower left-hand corner. This is how I designed the system for this particular project. And some other time, it may be some other way. But this is how it worked for me, and that's what I'm planning to do. And finally, model resolution. Okay, I selected high resolution to the 3x, 3 times slower than normal. And the reason I did that is so that we want the final product to be high quality, that's all, okay? If you can make it very high, that will be extremely slow. It takes forever to finish it. If you make it standard fastest, this may not be so good. So select the high and 3x lower. I selected the oak, dark oak, okay? And that looks very good to my eye. And the piece of wood I will give you, poplar, the piece of wood I will give you will be balsa wood, but I could not find the balsa wood, so I selected oak, okay? And the difference between balsa wood and oak is very tough wood. And balsa wood is extremely soft, but the difference is to my advantage. So the CNC machine will treat it like as if it's a tough wood, okay? And actually when the wood is soft, okay? So I'm gonna click OK. At the lower left-hand corner, there's a button, OK button, click on it. All right, here it goes. The numbers I gave you, okay, demonstrates a rectangle piece, and 2D view. In 3D view, it's going to look like that, but please don't pay attention. Go to 3D view tab, click on it, keep the 3D view tab like that. And now I'm going to draw some lines on it so that to make the impressions to create a profile on this. You're looking to the piece of wood from top down. The total length is 12 inches, this length is representing 12 inches. And the Y coordinate is this way, and it's representing 2 3/4 of an inch, okay? So on the left side, there is this menu, 2D line menu, and all kinds of applications of the 2D lines. And I'm looking for a line, and I find the line over here. It says draw line, polyline, okay? So I am selecting this line command, polyline command, click on, right at the corner, I'm moving cursor very accurately, okay, right at the top left corner, and click, and move my cursor down. As I move my cursor down, I see coordinates on the left, on the right-hand side of my cursor. And I'm continuing bringing down until I see 1. For the length of the line, angle is 90 degrees, length of the line is 1 inch. And I'm gonna click at that point and hit escape key. So I created one vertical line from the top left-hand corner, 1 inch down, okay? I need another line, okay? So I'm now clicking on the polyline command, moving my cursor to the top left corner where I left, go all the way to top right corner, and click on the top right corner. Go down all the way down to the lower right corner, click on it, and press escape key so that I can come. So I created 1, 2, 3 lines. The problem is, these last 2 lines I created is not connected to the first line. What do? I press the shift key and click on the left line. Top line is already selected. Now I need to join these 2 lines, and the command for that is here, join the close vectors. So there's the join line command here, where you see here. Click on it. So this way, all lines are connected. How do I know? Click outside, click the line. Now all three lines are selected. So click outside again. That's what I wanted to do. Now, another group of line I'm going to choose. Again, draw line, polyline. Click again, one more time. This time I'm bringing my cursor right over underneath where I started the first line. Click. I'm moving down to the lower left corner. Click. I'm moving my cursor to the lower right corner. Click. And hit escape key. This way I can connect it. Two lines. I created two lines. If you click on it, you'll see one vertical line, one horizontal line. So now I am prepared to create the profile line that is a draw curve command. This is not the first one in the middle, like this draw curve line, as you can see. Click on that. I'm moving my cursor. I'm trying to find out where the line is. I can see it. Hit escape key, click on it. Yes, now I can see. Click on this. Okay, now I can see end of the line. Click on the draw curve line. This is a click on it, and you move your cursor over where the end of the line is. Now I am creating a wheel fender like this, that, and like this. Okay. And I'm moving my cursor to the corner, and I'm done. I'm done. Hit escape key. Okay. So that's the profile I wanted to create. Because it's been already selected, I'm going to copy this profile. So Control C for copy. Okay. Now I'm going to join this line to the top line. So if you click on this and select the join line command, I just used it before. Click here. I'm sorry, Control Z. I'm taking back. I made a mistake. I'm going to click on the spline and press the shift button. I'm going to click on the other three lines I earlier created. Now these four lines are selected. Now I'm going to join them where they meet at the same point. At the join command, click on it. So this way, I actually created four lines together in one piece. Good. And I'm going to do the same thing, but remember I copied this before with the Control C. Now I'm going to type Control V to insert that, what I copied earlier. So there is, you see the old line, but actually there is a new line came here. I'm going to press the shift button and I'm going to select the bottom line, two lines at the bottom. Now I'm going to join these two also as well using the join close vectors by moving endpoints to common point button. Click on it. Okay, I think it worked, but I want to test it again. Click outside and go back and check the bottom line. Click. Everything I have generated is selected. It shows you it is selected. I can see that. If you don't see it, I can come and help you over there, but it's supposed to be, it's created, generated. Okay, so now I created a closed polyline here and another closed line on the top. So what is happening? Why am I doing this one? This part that you're looking is going to be removed. The machine is going to cut this part. Machine is going to leave this part alone. Okay, that's what we want to do. And there will be wheels here and wheels here. Okay, good. So I think I'm done with the line work. Now I'm ready to go to modeling, 3D solid modeling. So I'm going to click on 3D solid model tab at the very bottom. When you click on the 3D model solid model tab, one of the things you'll get your screen menu change on the left side. Okay, the very first 3D modeling tool happens to be create a shape from vector lines. You can only pick one at a time. So I'm picking the top model and click first. You select the top closed polyline. Okay, then you're going to move on, create shape from vector outlines, button top left corner. This is one of the first modeling tools. Click on it. Okay. So if you look at the 3D model, you see nothing is happening yet. And you can check it out back and forth. And one of the things you can do, if you click on the shape profile, there are 3 shape profiles. Okay, you can just bring it down to minus 90-degree angle. Then click here, the flat depression. Okay. Now, I'm not sure what's happening, but color is changing here. So something is happening, obviously. So I go to 3D View tab, click on it, and I go change the view to 3/4 view. And I'm going to click on Apply button. See if it's going to change anything. Nothing has changed yet. I'm going to, base height is going to be down here, this much. 0.812. But then I just remember that number happens to be minus 1.625. So I wonder if we can minus 1.625. Now enter, see what happens, and click apply again. Okay, so that line, okay, that surface came down to where it's supposed to be, minus 1.625, at the very bottom. This is the part we want to machine it. Because I like it, I like what's happening, but I like what I see, I click apply and start a new component. Okay, so how do you start a new component? Pretty much the same way. We're going to click on and close. We're going to click on this time the bottom part, closed polyline. This is the closed spline, closed polyline. And then we're going to click on create a shape from vector outlines. Click here. Remember, you press the start new component. That's the important part. And this part should be, I'm clicking on the top shape profile. Angle should be perpendicular up, all the way up. But, 90 degrees. But I'm going to select the flat profile, not the round profile. And now, computer shows me the base height is not high enough. So I'm going to take it all the way up here and back to 0. I'm going to change this to 0, enter. Okay. And now I'm going to click on apply button because I like what I see. That's why I'm saying apply button. Okay. And I'm done. Now close. So this is the impression that what I like to find out. What happened? Well, basically, I created the solid model. The profile of the cut of the rocket car. Rocket car, okay, will have a profile like this so that we can add the wheels here and holes here, and then we can do many other things in addition to, okay? And for that to happen, we need to create a toolpath. So I'm suggesting you take your cursor over the toolpath on the top right corner of your screen. Click on the toolpath. Click, okay? And this is the time to move your cursor over 3D finishing toolpath. So you select that, okay? At the very bottom, there is something called calculate. So click on it. Now, computer on the lower left-hand corner, you'll see computer started calculating. There's really a lot of mathematical calculations going on right now behind the scenes, okay? And you will be glad that you're not doing those math because there are so many thousands of calculations per second going on. But it's doing it, and we'll see what's going to look like at the end. It's going to demonstrate. Now, you would think that it's finished by creating toolpath and solid model. There is a little bit more left to do, such as saving the solid model and saving the toolpath. Okay, so this is the final product. We are very close to final product, but I like to see how it goes. So click on the run button. You want to preview the selected tool. You want to click on the run button. There's a plate. It literally simulates. It literally simulates the cut process of the material into your design. And literally you can see. Oh, by the way, I'm using 1/8 of an inch drill bit or CNC bit, router bit, 1/8 of an inch. So some of you, I already set it up. I didn't show you that, but some of you may have to adjust the tool set and tool bit to 1/8 of an inch drill bit. Okay, so basically the simulation shows me the machine is cutting the material the way it is expected, the way it is designed. And so how do we save this? How do we get to the machine? How do we make sure that the system sends all the information to the machine? That's a very good question. Okay, how do we do that? Okay, this is pretty much the way right now you can see the cut is made. It's all aerodynamic shape and everything. It's ready to make some holes for the wheels and put the wheels in it. And there's a hole here that originally exists in the wood that I gave you. Okay, that's why according to that dimension. All right. So how do we save this? Saving two process. Okay, one of them is you save the file. Go to File and go to Save As. And you're supposed to go to your OneDrive. I'm supposed to go to my drive and I'm just going to call it Ege Rocket. If it ever makes sense. Save. But I only saved solid model. I did not save the toolpath. To save the toolpath, you need to go to Toolpath and finally close the toolpath at the very bottom. Computer will give you a chance. And then you move your cursor over lower right-hand corner icon where it says Save the Toolpath. Click on it. Okay. And finally, in the long list of the toolpath formats, you have Axiom CNC MMG format. This is the one that our Axiom CNC machine is using it. So I suggest, okay, click on that. Okay. All toolpaths are okay, very good. And close and save. Okay, toolpath is selected and you go to save the, I'm sorry, it has to be selected. Toolpath has to be selected first. And so that you select the type of file that's .mmg file and then save, then there's a button, save toolpath button here. And then you should type your own name, okay? Say John's Rocket Car. or Alan's rocket car, okay, Gina's rocket car, all right? And this is Axiom and .mmg type, and click on the save button. So basically, I'm going to come up there with the flash drive, unless you have your own flash drive with you, and take it to the CNC machine and make it work. Okay, that's how it is. Thank you very much for your time, and I think you have a good time, and you're going to spend even have more good time when you're doing the assignment. If you have any problems, and nothing goes perfectly, you should have a problem on occasions, then call me and let's solve those problems together. This is an adult program. It's designed for the adults and college graduates and so on. But it literally is the very heart of manufacture, automated manufacturing, systems engineering, computer-aided design and drafting systems. So it really, in the long run, will help the country and you and everybody around us. Okay, and this is not the future. This is currently happening today. So the CNC machines are working in the factories and manufacturers, offices, all day long, and this is it, folks. And give it a try. And thank you very much for your time. Have a good day.